is 40.53 years based on my sample. Okay, but I can say, parallelly, I can also state that based on the 95% confidence interval for mean, it can be stated that the medical tourist or the domestic medical tourist from the Tripura to Kolkata is varying between the age group of 37.71 years to 43.36 years. Okay, this is for the population. The confidence interval gives you, it empowers you to talk about or to state about the population data, right? I can say that based on my sample, the mean age of tourists coming from the Tripura to Kolkata is 40.53 years based on the sample. But I can also state that based on the 95% confidence interval, the age group varying between 37.71 to 43.36 years. This is for the population. This statement is for population. Okay, understood? Any question here? Any question from this part? Understood?
No question, ma'am.
No question means understood, no?
Yes, ma'am.
Similarly, you can state for the other states also, and you can comment on the differences. Kahan se younger are, like if you're a decision maker, or if you're a planner, or if you're a researcher, you can easily comment that maybe the age group varying from which country, from which states the younger patients are coming, from which states the older patients are coming, right? That I can draw for the population based on the sample. Okay. Similarly, for the Mizoram, from the Sikkim, and so on. Then we have an approximate expenditure, right? Expenditure. Similarly, you can comment for the expenditure also, that which state is like spending more, which state has the more purchasing power capacity, right? So who are like more higher spender. So obviously, if you're a hospital owner, so you will be loving to invite those who are spending more, if you're a business owner, right? So in that scenario, we can do analysis and we can comment and we can further plan accordingly. So this is about the exploring descriptive statistics based on the factors and number together. Okay. If I scroll down, this result is a huge result. I can further see I got the data when I click on outliers. I can also see I got the data for the extreme values, right? I got outliers for the highest case scenario. Tejasvi, this is for you. See, I got the data for the highest case scenario. I got the data for the lowest case scenario as well, right? So I can see that my highest top 5 outliers, top 5 extreme values, and bottom 5 and the bottom extreme values. Just give me a moment. So I can see easily my bottom 5 and top 5 extreme values. Okay. Now, see the case value. Value money for the age, the value is this one. Value age. For the expenditure, the value is in INR. Remember, value means the actual number that we have observed value from the data, right? And then you have a case number. Suppose it is saying that for Tripura, the highest, the extreme outlier is 65th case, 65 number case, where the value is 66 years. Do you want to cross check? Just go back to your data set, data view, and come down to the case ID 65. See, 65. From Tripura, patient age is 66. This 66 for the Tripura, maybe it's not possible for me to go through with this data and identify which is outlier for Tripura. But yes, on the basis of the analysis, I can tell in a minute that from the Tripura, the outlier is 66. Now it's up to you, it's up to the researcher, like how many outliers they want to identify, or they want to retain in the study, or they want to remove from the study. This is completely objective based analysis. No one can comment on this. It's me being a researcher, it's my opinion, it's my observation, it's my thought process, my requirement, whether I want to remove or whether I want to retain this outlier in my data set. So this is my case number 65. For the similarly lowest one, I got the 20 years. It's an extreme low value, 20 years. Okay. Case number 2 for Tripura. So go back here, see the case number 2, 20 years. Got it? In this way, I can identify my case, that which case is giving me outlier in the data set. And this we can do for the any of the observation. Okay. I can do for the Assam, I can do for the Arunachal Pradesh. Even you can do the same for the any of the n numbers of the continuous item you are having in your data set. Right? You can bring all ones together and then you can identify. Similarly, you can see for the Assam. Say for the Assam, the 93 case number is the most, it's the highest outlier. We are spending 2 lakhs, right? Or the lowest one is the 12,000. 82 number case. Let's see the 82 number case. See the 82 number case. 16-year patients spending minimum amount. It's a 12,000 he is spending on the expenditure. It's a extreme, it's a bottom most outlier. Okay. So we have, based on the nature of the outliers, we may have the outlier at the extreme higher end or extreme lower end. Higher end, which is more than mean. The value is higher than mean. Lower means value is lower than mean, or lower than average. Okay. So I can identify in this manner extreme values. If you want to show, I'll come on the normality test later, not now. If I want to show the same in a histogram, I'll show the histogram also. Okay. You can see the histogram. This is already created for the Tripura. Histogram for the age. Okay. You can see the histogram for the state of Assam. You can double click it and then you can change the colors and everything, whatever you want. Just like an Excel sheet, you can apply and you can do. Okay. I can change accordingly. You can see. Okay, then later you can explore how we can change the design and everything. But I got the histogram here. I got the histogram for Arunachal Pradesh, for Mizoram, for the Sikkim. Okay. Similarly, you will be getting the histogram for the other states too. For the expenditure also.